Hi, welcome back. This is Professor Ridge and today's lesson on section 4.3, absolute value equations and inequalities. So we'll first start off with the absolute value. The definition. Alright, so in algebra we define it this way. So absolute value of x is equal to, now there's two cases. If x is a positive number or 0, then you leave it alone, you just drop the bars. So the absolute value of 7 is 7. Now if it's a negative number, if x is a negative number, then we say, okay, if I want to do the absolute value of negative 7, then I'm going to change the sign and make it positive 7. So the way we write the notation for that is the opposite of x, not negative x, the opposite of x. Okay, so that's the way we define absolute value in algebra, making a split function. Now, another way to think of it, of course, is distance. So if I ask you to find the solution set. Okay, so find the solution set for the equation absolute value of x equals 5. Now I can use the definition above and say, well, remember the solution is something that makes this a true statement. So what can you put in for x that when you do the operation it's going to be equal to 5? So you can put in a 5 in there. Okay, so 5 is the solution. Or you can put in negative 5 in there because absolute value negative 5 equals 5. So negative 5 is also a solution. So you'd say x equals 5 or x equals negative 5. If you write it as a solution set, of course you would just put it in your braces like this, negative 5 or 5. Now, I was mentioning we can also think of this as distance. Absolute value is distance from 0. Okay, distance of number x is from 0. So if I said the absolute value of x is equal to 5, we're saying the distance from some number and 0, some number x and 0 is 5. So if here's 0, what's 5 units away? And of course you could be, that's 5 units. So you'd be right there. Then going the other way to negative 5, that's also 5 units away. So of course the solution to absolute value of x equals 5 is x equals 5 or negative 5. So if I think of the geometry that way, the distance. Alright, so B for example 1 is solve absolute value x equals 0. Well, if we think of distance again, the only number that's 0 distance away from 0 is 0. So this only has one solution, x equals 0. And then for C, absolute value of x is equal to, say, negative 3. And then the idea is, well, absolute value of a number, when I perform the absolute value, I'm guaranteed to get either 0 or a positive number. So when can a 0 or a positive number be equal to a negative number? The answer is never. So this has no solution. Okay, and we make a rule for that. So let me write that down. Okay, so from A above, we know that the absolute value of x is equal to some number, you're going to get two solutions. So here, we're saying for any positive number p, so we're being specific, p is positive, and then we're going to change just x to any algebraic expression. It could be more complicated than just x. But if you have something inside the absolute value is equal to a positive number, then we know that whatever that expression is inside the absolute value could be equal to, we have the two cases. It could be the opposite of whatever that number p is, or it could be equal to p itself. Okay, so we got two cases. It could be the opposite of p, or it could be equal to p. And then you just solve those equations. And then from b, the solutions for absolute value of x is equal to 0. You could just drop the bars and solve it without the bars. And then for c, if you have the equation, an expression in the absolute value equals a negative number, well, we just talked about it. Absolute value of anything is going to give you a positive, so there's no way that this could ever be true. So that has no solution. So no work to do for there. You don't have to do anything. Just know that automatically you're not going to get any solution for that one. All right, let's try number 22. It's an exercise from the book. So we got 5x plus 2 equals 7. So we got an algebraic expression, absolute value of an algebraic expression equals 7. So what I'm going to do is the two cases, and I don't care whether you write the plus 7 or the minus 7 one first. But I'll just do it the way I wrote it there. Or 5x plus 2 equals negative 7. And then you solve both of these equations separately. So we'll do that on the next page. Okay, so we'll do the left one first. You're going to subtract 2 from both sides. So that gets me negative 9. Divide both sides by 5. So that gets me negative 9/5. Now we're going to do the right equation. Subtract 2. Like 7 minus 2 is 5. Divide both sides by 5. So x equals 1. So our two solutions are negative 9/5 or 1. Okay, if we look at exercise 24, we see we got this absolute value of 7x minus 2, and that equals a negative number. And so by the property C, we know that a positive or 0 can never equal a negative number, so this automatically has no solution. So we're done. So the solution set's empty. Okay, so let's look at number 40. Now the key is, if you go back and look at the last page at the principle for the absolute value principle for equations, notice it has to be absolute value expression equals a number. So before I apply the rule, I have to get this absolute value by itself. Okay, so you got to get that by itself. When absolute value of something equals a number. So I'm going to add 7 to both sides, just kind of pretending like that was a, just a big W or something. So I have 3 absolute value of 2x minus 5 equals 6. Now I'm going to divide both sides by 3 to get the absolute value by itself. Now once the absolute value is by itself, now you can apply the rule. So the rule is if you got an absolute value of an expression equals a number, a positive number, you have the two cases. You drop the bars, make it equal to the opposite of that number, or just drop the bars and leave everything the same. And now solve these two equations separately. So we're going to add 5 to both sides. That gets me 3. And then divide both sides by 2. That gets me 3/2. Now we do the other one. Add 5 to both sides. So that gets you 7. Divide both sides by 2. So it gets you 7/2. And my two solutions are 3/2 and 7/2. Alright, now number 48, we got absolute value x minus 7 equals absolute value of 2x plus 1. Now, we can't use the absolute value principle on this one, but you're in luck. The rule is if you have one absolute value on both sides and nothing else, then basically there's two possibilities. This to be a true statement, the numbers in here could be the same number, or they could be opposites. Okay, so those are the two cases. So same number meaning like this one could be -8 and this one could be -8. In both cases, absolute value of -8 is 8. Absolute value of -8 is 8, so that would be a true statement. The other possibility is like this one over here, it could be a -5, and then this one could be a +5. So if I had -5, -5, that would be the case for the same number, or I can have +8 equals -8. See, so both of those would give you true statements. So the way that you do this is, case 1 is you just drop the bars. So that would be the same number. So we're going to solve it so both numbers inside are the same number. Or, then we want opposites. So what you do is you put an opposite sign in front of one of them, not both. Okay, and then you solve those two equations. So this is your case 1. They're the same number. Case 2, they're opposites. So you solve both of those separately. So let's see, let's subtract 2x. Add 8. Divide by -1. So x is -9. Oh, this should have been 7. 7. I was thinking the answer when I wrote down 8. That would give me 8. So that would give me -8. Okay, I'm going to distribute my minus sign. So the other way you can think of it is just change all the signs on one side. That's the net result. Okay, I'm going to add 2x. And I can't emphasize, you change it on one side only, not both sides. Add 7. Divide by 3. So x equals 2. So your solution set is -8 or 2. Oops. And I can check. So if x equals -8, we're asking this question. So you get -15. Absolute value -15 is 15. Over here you get -16 plus 1. Okay, and you can see both numbers inside are the same. And when you take the absolute value of both sides, you get +15 equals +15. Check. Now I can do the same for x equals 2. Let's see if I can squeeze it in here. So we're going to check x equals 2. So we get 2 minus 7. Does that equal 2 times 2 plus 1? I watched all the work, but this would be absolute value -5, which equals absolute value of 5. You see those are opposites of each other, but when I take the absolute value of both sides, you get 5 equals 5. Check. Alright, so that is equations. Now moving on to absolute value inequalities. So on the next page. Okay, so let's look at the three things here. So absolute value of x equals 4. Now if we're thinking distance again, think distance. We want that the distance between x, some number x, and 0 to be 4 units away. So here, this is 4 units. This is 4 units. So if x could be exactly equal to 4 units away, where could you stand? And the answer would be you could be standing at x equals 4 or x equals -4. Now again, if we're thinking distance, we want the distance between some number and 0 to be less than 4 units. So if we think about our number line again, here's 0, here's -4, which is 4 units away, and here's +4, which is 4 units away. So where could you be standing on this number line if you were less than 4 units away? So at -4 and 4, those are equal to 4 units, so to be less than 4 units away from 0 would be all the space in between. So that solution set would be the interval from -4 to 4, which we could write it using inequalities, or we could write it using interval notation. Okay, now if we want the distance to be greater than 4 units, where could you stand on this number line and make that a true statement? So here's 4, -4. At 4 and -4, that would be equal to, you want to be greater than 4 units away, so you can be out here at 5, 6, 7, on out to infinity. You could be at 4.01. And then also, you could be out here at -4.01, -5, -6. So it's those points that are beyond. Remember, we're in reference here. Here is 4 units, so you could be outside of that. So that would be over here. From 0 to 4 is 4 units outside of that. So you're going away. Distance is greater than 4. Now, we could translate this piece using inequalities as x is less than -4, or this piece translates to x is greater than 4. Okay, so those are the three cases we talked about: absolute value equations and inequalities. Let me write that down. Okay, so the three cases for the principles for solving absolute value problems. Whenever you have an absolute value problem, the technique for all is the same. You get the absolute value by itself equals a number, a positive number, and then you do the case according. If it's an equation, you split it up into x equals -p or x equals p. If it's absolute value of x is less than p, that's equivalent to this statement: -p is less than x is less than p. And then case C is absolute value of x is greater than p is equivalent to this OR statement: x is less than -p or x is greater than p. So you just have to either memorize this or go back to the way I drew it up there and think about distance and where it's coming from. But anytime you have or asked to solve an absolute value inequality, that's the greater than, less than one, you got to think greater than is the distance going away. Look at C up here. So it's those outside pieces, and it's an OR statement. less than, that's B, that's in between, because you want the distance to be less than some number, so you could be anywhere within that space. All right, let's try an example. Number 66, we want to get the absolute value by itself first. So x minus 4 is greater than 5. Now, we apply the rule above. Greater than, that's, again, if I think of the picture, if I don't have that memorized, I think, okay, greater than is the outside pieces. So if this was just an x, not x minus 4, I would think of this. So I want x is, my algebraic expression is greater than 5, or x is less than negative 5. So you just got to remember that. Just straight memorize it or kind of walk through it the way I just did. So we're going to get the expression in the absolute value is less than negative 5, or the expression inside the absolute value is greater than 5. Now solve this compound inequality. And we do it separately. So x is less than negative 1, or add 4, x is greater than 9. That'll be the graph. So we go to negative 1, open circle, or use a parenthesis, whichever. I guess I've been teaching with parenthesis. Goes this way. And then go to 9, greater than. So our solution set in interval notation be negative infinity to negative 1, union 9 to infinity. All right, let's try another one. All right, number 78. Again, we want to get the absolute value by itself. So 26 minus 7 is 19. Now less than, this is a less than statement, so you got to remember that's in between. So we're going to take 4a minus 5 and sandwich it in between two less thans. Be negative 19, 19. And then think of this as having three sides now. We're going to add 5 to all three pieces. So we get negative 14 is less than or equal to 4a, less than or equal to 24. And divide all three pieces by 4. We get 7/2 is less than a, less than or equal to. And then our graph will be wherever negative 7/2 is, 12, and we're using brackets, shading in between. So our solution set is negative 7/2 to 12, inclusive. Okay, I'm going to do a couple other examples. So number 68. 3y minus 4 is greater than negative 8. Now, on this one, okay, we haven't talked about this yet, and I haven't written any rules, but if I go through the motions and greater than statement is you're going to change the symbol, change the sign, or 3y minus 4 is, then we leave everything alone. Work this out separately. So you get y is less than 4. Do this one. Divide by 3. Y is greater than negative 4/3. Now when you look at the graph, remember this is an OR statement, so y is less than 4 is this piece. X, or y is greater than negative 3 is this piece. And then you can see negative 4/3, sorry. And you can see that actually that's equal to the negative infinity to infinity. It's the whole number line. And so basically all real numbers solution. We could have done that without doing any work, just by realizing, oh yeah, if we got absolute value, this is positive or 0 always. This is negative. So tell me when a positive or 0 number is greater than a negative number. And the answer is always. So this solution set is all real numbers. So it's negative infinity to infinity. And I didn't have to do any work. So you can pay attention to that. Now if we do it the other way, if that was less than symbol, when's a positive number so this would be a different problem totally. Let me get a, let's say negative 10. So let's say a problem like that. When is a positive or 0 less than a negative number? And the question is never, right? Positive is always greater than a negative, so this one would have no solution. Okay, so if it's a greater than statement, greater than a negative, all real numbers. If it's less than, then that's no solution. So you got to be careful. Don't just automatically assume it's no solution. This one is, it's infinite number of solutions. It's all real numbers. Okay, let me do one more, and then that should conclude this lesson. Let's use this function notation, number 86. We got f of x. Okay, so find all x for which f of x is less than or equal to 3. So the idea is you were trying to solve this inequality for x. So what you're going to do is take this f of x out and put in what it's equal to. Well, it's the absolute value from the line above. It's the absolute value of 5x plus 2, and then you're going to put minus is less than or equal to 3. So basically we're just going to substitute in what f of x is defined to be from the line above, and now solve this equation. So that's all they're asking us to do. Okay, it's a less than statement, so you got to remember that you're going to sandwich the expression inside between negative 3 and 3. You're going to subtract 2 from all 3 pieces. Divide all 3 pieces by 5. So x is between negative 1 and 1/5. So if I graph that, negative 1, 1/5, it's nice when you don't label it. Equal to is including it, so it's going to be the brackets. So my solution sets between negative 1 and 1/5. Alright, so that concludes the lesson for 4.3. Go to my math lab and complete your exercise there. I'll see you next time.